Welcome to Azure Service Endpoints. Welcome everyone. Today we're going to dive deep into Azure Service Endpoints, one of the most important networking features for securing your Azure infrastructure. I've been working with Azure for several years now, and I can tell you that service endpoints have been a game changer for many of my projects. They solve a fundamental problem. How do you securely connect your virtual machines to Azure services without exposing traffic to the public internet? In this presentation, we'll cover everything from basic concepts to hands-on implementation. By the end, you'll know exactly when to use service endpoints, how to configure them properly, and how to troubleshoot common issues. We'll be using real Azure CLI commands throughout, so you can follow along and implement this in your own environment. Let's get started. What are service endpoints? Let me explain what service endpoints actually are and why they matter. Think of service endpoints as a dedicated highway between your virtual network and Azure services. Without service endpoints, when your virtual machine needs to access Azure storage or SQL database, the traffic goes out to the public internet and then comes back in. It's like driving from your house to your neighbor's house by going through downtown. It works, but it's not efficient or secure. Service endpoints create a direct route through Azure's backbone network. This means better performance, lower latency, and most importantly, your traffic never leaves the Azure infrastructure. The diagram shows this perfectly. Notice how the traffic flows directly from the subnet to Azure services without touching the internet. This is what we call keeping traffic on the Microsoft backbone. This is particularly important for compliance scenarios where you need to ensure data doesn't traverse public networks. When should you use service endpoints? This is one of the most common questions I get. Should I use service endpoints or private link? The decision tree I'm showing you is based on real-world scenarios I've encountered. Service endpoints are perfect when you're cost-conscious. They're completely free. Private link, while more feature-rich, costs money for each endpoint. If you need to connect to multiple Azure services from the same subnet, service endpoints are incredibly efficient. You enable them once per service type, and all resources of that type become accessible. However, if you need cross-region connectivity or dedicated IP addresses, you'll need private link instead. Service endpoints only work within the same region. I typically recommend starting with service endpoints for most scenarios, then moving to private link only when you need its advanced features. Multi-service architecture design. Here's a real-world architecture pattern I use frequently. Notice how each tier has different service endpoints enabled based on its needs. The web tier only needs key vault access for certificates and secrets. The application tier needs both storage for data and SQL database for persistence. The database tier has its own storage account for backups. This separation follows the principle of least privilege. Each tier only gets access to the services it actually needs. This reduces your attack surface significantly. What's beautiful about this design is that you can scale each tier independently, and the service endpoint configuration stays consistent. I've used this pattern for everything from small web apps to large enterprise applications. The key insight here is that service endpoints are configured per subnet, not per virtual machine, which makes management much simpler as you scale. Understanding traffic flow. This sequence diagram shows exactly what happens when you make a request to Azure storage with and without service endpoints. Understanding this flow is crucial for troubleshooting. Without service endpoints, your request goes through multiple internet hubs, each adding latency and potential security risks. I've seen applications improve response times by 20 to 30% just by enabling service endpoints. With service endpoints enabled, the traffic takes a completely different path. It goes directly through Azure's backbone network, which is highly optimized and secure. The most important thing to understand is that this happens transparently to your application. Your code doesn't change. The routing change happens at the network level. This is why service endpoints are so powerful for existing applications. You can improve security and performance without touching a single line of code. Getting started. Prerequisites. Before we start configuring service endpoints, let's set up our environment properly. These first commands are foundational. Every Azure project starts here. The AZ login command will open your browser for authentication. Make sure you're logged in with an account that has contributor access to the subscription you want to use. Setting the subscription is crucial if you have access to multiple subscriptions. I always do this explicitly to avoid deploying to the wrong subscription. Trust me, I've made that mistake before. The resource group acts as a logical container for all our resources. I'm using the East US region, but you should choose the region closest to your users for better performance. One tip: use consistent naming conventions. I prefix all my demo resources with the project name to make cleanup easier later. Creating the virtual network foundation. Now we're creating the virtual network that will house our subnets. The address space 10.0.0.0/16 provides approximately 65,000 IP addresses, which is plenty for most scenarios. I always plan my IP address space carefully. This /16 network allows me to create multiple /24 subnets, each providing approximately 250 usable IP addresses. The key parameter here is address prefixes. You can specify multiple address ranges if needed, but in most cases, a single large range works best. Notice that we're not creating any subnets yet. That's intentional. We'll create subnets with service endpoints enabled in the next step, which is more efficient than creating them separately and then modifying them. This virtual network will be the foundation for all our networking. Once it's created, we can start adding subnets with specific configuration. Creating subnets with service endpoints. Here's where the magic happens. We're creating a subnet and enabling service endpoints in a single command. This is much more efficient than creating the subnet first and then updating it. The service endpoints parameter accepts a list of Azure services. I'm enabling 3 of the most commonly used ones: storage, SQL, and Key Vault. Notice the address prefix 10.0.1.0/24. This gives us a subnet with 254 usable IP addresses, which is perfect for most application tiers. The service endpoint names are very specific. Microsoft.Storage covers all storage services: blob, file, queue, table. Microsoft.SQL covers Azure SQL Database and SQL Data Warehouse, and Microsoft.KeyVault covers Key Vault services. What's happening behind the scenes is that Azure is configuring special routes in this subnet that direct traffic to these services through the Azure backbone instead of the internet. Adding service endpoints to existing subnets. Sometimes you need to add service endpoints to subnets that already exist. This update command does exactly that, but there's an important caveat. When you use the service endpoints parameter, it replaces the entire list. So if the subnet already had some service endpoints, you need to include those in your command along with the new ones. In this example, I'm adding Event Hub to the existing list of storage, SQL, and Key Vault. Notice that I include all 4 services in the command. This operation can cause a brief connectivity interruption, usually just a few seconds, as Azure updates the routing tables. I always recommend doing this during maintenance windows for production environments. Pro tip: always verify the current service endpoints before running this command. Use AZ Network VNet Subnet Show to see what's currently configured. Creating storage account with security. Now we're creating the Azure storage account, but notice the default action deny parameter. This is a security best practice that I always recommend. By setting the default action to deny, we're blocking all network access by default. This means only explicitly allowed networks can access this storage account. The storage account name must be globally unique across all of Azure. I often include the date or a random string to ensure uniqueness. Standard LRS provides locally redundant storage, which is cost-effective for demo scenarios. In production, you might want GRS, geo-redundant, or ZRS, zone redundant, depending on your availability requirements. This deny by default approach is crucial for security. Without it, your storage account would be accessible from anywhere on the internet, which is rarely what you want. Configuring storage network access rules. This is where we connect the service endpoint to the storage account. The network rule tells the storage account to allow access from our specific subnet. The subnet parameter specifies which subnet is allowed to access this storage account. Remember, this subnet must have the Microsoft Storage Service endpoint enabled for this to work. What is happening here is that Azure is creating a firewall rule at the storage account level. Only traffic coming from the specified subnet through the service endpoint will be allowed. This creates a secure tunnel. The subnet routes traffic through the service endpoint, and the storage account only accepts traffic from that subnet. It is a two-way security mechanism. You can add multiple subnet rules if you need access from different subnets, but each subnet must have the appropriate service endpoint enabled. Setting up Azure SQL Database. Let's move on to SQL Database. First, we create the logical SQL Server, which is essentially a management container for your databases. The admin credentials I'm showing here are just for demo purposes. In production, you should use strong passwords and consider Azure Active Directory authentication instead of SQL authentication. The server name must be globally unique, just like storage accounts. Azure will append .database.windows.net to create the full server name. Notice that we're not configuring any network rules yet. We'll do that after creating the database. This follows the pattern of creating resources first, then securing them. One important thing. The SQL Server location should match your virtual network location for service endpoints to work properly. Creating the SQL database. Now we create the actual database within the SQL Server. The service objective S0 represents the standard tier with a specific performance level. Service objectives determine both performance and cost. S0 is perfect for development and testing, but production workloads might need higher tiers like S1, S2, or premium tiers like P1, P2. The database inherits the network security settings from its parent server, which is why we configure network rules at the server level, not the database level. This separation between server and database allows you to host multiple databases on the same server while maintaining consistent security policies. Once this command completes, you'll have a fully functional SQL database, but it won't be accessible from your virtual machines yet because we haven't configured the network rules. SQL Server Virtual Network Integration. This command creates the virtual network rule that allows our subnet to access the SQL Server. It's similar to what we did for storage, but the syntax is slightly different. The rule name, VNet Rule App Tier, is just a friendly identifier. You can use any name that makes sense in your environment. I like to include the subnet name in the rule name for clarity. Just like with storage, this subnet must have the Microsoft SQL Service endpoint enabled for this rule to work. The service endpoint and the network rule work together to create secure connectivity. Behind the scenes, Azure is configuring the SQL Server's firewall to accept connections that originate from the specified subnet and arrive through the service endpoint. This is more secure than IP-based rules because it's based on the network topology rather than potentially changing IP addresses. Verification is crucial. You want to make sure everything is configured correctly before deploying applications. These commands help you validate your setup. The first command lists all service endpoints on the subnet. You should see Microsoft.storage, Microsoft.sql, and Microsoft.keyvault in the output if you've been following along. The second command shows the network access rules for the storage account. This helps you verify that your VNet rule was created correctly and see the default action, which should be deny. The query parameter uses JMES path syntax to filter the output to just the information we need. This makes the output much cleaner and easier to read. I always run these verification commands after making configuration changes. It's much easier to catch configuration errors early than to troubleshoot connectivity issues later. Understanding service endpoint policies. Service endpoint policies add another layer of security on top of basic service endpoints. Let me explain why this matters with a real-world scenario. Imagine you have a subnet with Microsoft Storage Service Endpoint enabled. By default, this allows access to any storage account in Azure. That's probably not what you want from a security perspective. Service endpoint policies let you create an allow list of specific storage accounts. Even though the service endpoint is enabled, traffic can only reach the storage accounts you explicitly approve. The diagram shows this perfectly. The policy acts as a filter. The virtual machine can try to access any storage account, but the policy only allows traffic to approved ones. This is especially important in large organizations where you might have hundreds of storage accounts, but each application should only access its own data. Creating service endpoint policies. Let's create a service endpoint policy step by step. First, we create the policy container, which is just an empty policy that we will add rules to. The policy needs to be in the same region as your virtual network. Policies cannot span regions, which makes sense since service endpoints themselves are regional. Think of this first command as creating an empty rulebook. We will add the actual rules in the next step. The policy name should be descriptive. I often include the environment, for example, production or development, and the purpose in the name. Once created, this policy exists but does not affect any traffic until we add policy definitions and apply it to a subnet. Adding policy definitions. Now we add specific rules to our policy. Each policy definition specifies exactly which Azure service resources are allowed. The service resources parameter takes the full Azure resource ID. This is very specific. You're not just allowing any storage account, you're allowing this exact storage account. You need to replace your subscription ID with your actual subscription ID. The resource ID format is quite specific, so make sure you get it exactly right. This granular control is what makes service endpoint policies so powerful for security. You can ensure that each application only accesses its designated resources, even if they're in the same subnet. You can add multiple policy definitions to the same policy to allow access to multiple approved resources. Finally, we apply the policy to our subnet. This is when the policy actually starts affecting traffic flow. Once this command completes, any virtual machine in this subnet will only be able to access the storage accounts explicitly allowed in the policy definitions. All other storage accounts will be blocked. This is a significant security change, so I always recommend testing thoroughly in a development environment first. You don't want to break production applications by accidentally blocking access to required resources. The policy enforcement happens at the Azure network level, so it's very reliable. There's no way for applications to bypass these restrictions. If you need to add more storage accounts later, you just add more policy definitions to the existing policy. You don't need to recreate everything. Access control architecture. This diagram shows the complete security flow when you combine service endpoints with network security groups and Azure service firewalls. It's defense in depth at its finest. Every request goes through multiple security checkpoints. First, the NSG rules check if the traffic is allowed. Then the service endpoint routes it through the Azure backbone. And finally, the Azure Services Firewall checks if the source subnet is authorized. This multi-layered approach means that even if one security mechanism fails, others are still protecting your resources. It's how we build truly secure cloud architectures. Notice that traffic can be denied at any of these points. This gives you fine-grained control over network access patterns. I've seen environments where this approach prevented security breaches because attackers couldn't bypass all the security layers even if they compromised one component. Monitoring and alerting strategy. Monitoring is absolutely critical for service endpoints. This architecture diagram shows how all the pieces fit together for comprehensive monitoring. NSG flow logs capture detailed network traffic information. Azure Service Metrics show access patterns and performance. All of this data feeds into log analytics for analysis. The beauty of this setup is that you can correlate data across different services. For example, if you see SQL connection failures, you can check NSG flow logs to see if traffic is being blocked at the network level. Azure Monitor provides the central nervous system for all this data, while Log Analytics gives you powerful query capabilities to analyze trends and troubleshoot issues. I always set up comprehensive monitoring before going to production. It's much easier to troubleshoot issues when you have good visibility into what's happening. Systematic troubleshooting approach. When service endpoints don't work, there's usually a systematic way to troubleshoot them. This flowchart represents my tried and tested troubleshooting methodology. I always start with the basics. Is the service endpoint actually enabled on the subnet? You'd be surprised how often this is the issue, especially in environments where multiple people are making changes. Next, check if the VNet rule is configured on the Azure service. Remember, service endpoints are a two-way configuration. Both the subnet and the Azure service need to be configured properly. NSG rules are often overlooked but can definitely block service endpoint traffic. Make sure your NSG rules allow outbound traffic to the appropriate service tags. Following this systematic approach has saved me hours of troubleshooting time. Don't skip steps. Even if you think something is configured correctly, verify it. Summary and best practices. Let me wrap up with the key takeaways from our deep dive into Azure Service Endpoints. Service endpoints are incredibly powerful for improving security and performance while being completely free to use. They're perfect for regional architectures where you need to connect to multiple Azure services securely. Remember the key limitations. They only work within the same region, and they don't provide dedicated IP addresses like Private Link does. Choose the right tool for your scenario. Always implement defense in depth with NSGs, service endpoint policies, and Azure service firewalls. Don't rely on just one security mechanism. Set up comprehensive monitoring from day one. Good monitoring makes troubleshooting much easier and helps you identify issues before they impact users. Thank you for following along with this presentation. Service endpoints are a fundamental building block for secure Azure architectures, and I hope this deep dive has given you the knowledge to implement them confidently in your own environments.